Hello guys, it's primary and secondary tutorials here today, and I'll be showing you how to solve a rational function. So you see, we have our equation here today, and everything is factored out for us already besides x squared plus 4x plus 4. So let's get that factored, and while we're at it, I'm going to show you a little trick how to factor. So, we have our ax squared plus our bx plus our c. The last term is our c value. So we're going to take that and put a little line under it. And we're going to find a number that adds to our b value and multiplies to our c value. Our second term is our b value. 1 and 4, it adds to 5, multiplies to 4, does not work. 2 and 2, adds to 4, multiplies to 4. That does work. So we will take that, and now we have x plus 2 times x plus 2 over x plus 2 plus x plus 3 over x plus 2 equals 5. Now, I like to put my 5 over 1 since it is just a whole number, and it helps me not get so mixed up by having a fraction for each one. Now we must identify our least common denominators, or LCDs. And you may ask, why do we have 3 denominators but only 2 LCDs? 2 of our denominators are the same, so we do not need to put it again. And what's different here is that when you're solving something, you need to multiply all the LCDs by all the numerators. So we'll have x plus 2 times x plus 2 over x plus 2 plus x plus 3 over x plus 2 is equal to 5 over 1. Now, we're going to add our LCDs to our numerators. So, we will get x plus 2 times x plus 2 times x plus 2 over x plus 2 plus x plus 3 times x plus 2 over x plus 2 is equal to 5 times x plus 2. And here we have this 1, but since I put that fraction, you will only put the 1 for the 5. Now our goal here is to completely eliminate any denominator. So here, unlike addition and subtracting rational functions, we will cancel. So we're going to cancel out our 1 and cancel out our x plus 2 from both fractions. And so here, we have x plus 2 times x plus 2 plus x plus 3 is equal to 5 times x plus 2. So let's multiply. X plus 2 times x plus 2 is what we just factored earlier. It will be x squared plus 4x plus 4 plus x plus 3 is equal to 5 times x, which is 5x, 5 times 2, which is 10. Now we combine like terms. 4x plus x is just 5x. Four plus 3 is 7. So now we have x squared plus 5x plus 7 is equal to 5x plus 10. And now we're going to subtract 5x plus 10 from both sides. But I'm going to do it in a way that makes it a little bit less confusing. So we're going to do x squared plus 5x plus 7 minus 5x minus 10. You're going to set it equal to 0 because now there's nothing on your right side of the equation. And again, you're going to combine like terms. So 5 plus negative 5 cancels out to be 0, so we no longer have a b value. We have x squared plus 7 minus 10. Now you can treat this as 7 minus 10 or 7 plus minus 10 or negative 10. It acts the same way. You're going to get x squared minus 3 is equal to 0. Now we move our 3 over. We're going to plus 3 on both sides. So now we have x squared is equal to 3. But since our x is squared, what must we do now? We're going to square root it. so it gets rid of that square, but we have to square root both sides. So now x is going to be equal to the square root of 3, or x equals plus or minus square root 3. Here, we have a different equation, same denominators, different numerators. So, everything else is factored out for us already. So, what we're going to do is we're going to take our c value, and we're going to see what multiplies to my c value while adding to my b value, as listed here. So, 8 and 1. Multiplies to 8, adds to 9, that does not work. 4 and 2 multiplies to 8, adds to 6, that does work. So now we're going to have x plus 4 and x plus 2 over x plus 2 plus x minus 2 over x plus 2 is equal to 6. And again, we're going to put it over 1. And identifying our LCDs, again, since we have two denominators that are the same, we will have two LCDs. So our LCDs will be x plus 2 and 1. So what will that look like in our equation? We'll have x plus 4 times x plus 2 times x plus 2 again over x plus 2 plus x minus 2 times x plus 2 over x plus 2. And that's going to equal 6 times x plus 2 times 1. And remember, our goal again is to get rid of all denominators. So we're going to cancel out what matches. Get rid of the x plus 2s and get rid of the 1s. And now we have a regular equation. We're going to have x plus 4 times x plus 2, and that's going to equal out to x squared plus 6x plus 8. And now we're going to have plus x minus 2 is equal to 6 times x and 6 times 2, which together that brings us to 6x plus 12. Now again, we must combine like terms. So 6 plus 1 is equal to 7, so we'll have 7x. And 8 plus negative 2 is equal to 6. So we have x squared plus 7x plus 6 is equal to 6x plus 12. And again, we got to subtract 6x plus 12 from both sides using system of equations. So now we'll have x squared plus 7x plus 6 minus 6x minus 12. And so we're going to combine like terms again. 7 plus negative 6 is just 1. 6 plus negative 12 is negative 6. So let's factor this. Let's use our trick again. But see, we have a minus and a plus sign and not just two pluses. So here, we're going to use our c value. And this time it has to multiply to our c value and it has to subtract to our b value. And this minus sign also means that we will have different signs in both of our factors. But this plus sign is going to tell us that the biggest factor is going to get the plus sign. So let's see. 6 and 1 multiplies to 6. It does not add to 1 or subtract to 1. 3 and 2 multiplies to 6, subtracts to 1. And the biggest factor gets the plus. So 3 will get the plus, and 2 will get the minus. So we will have x plus 3 and x minus 2. So here, we're going to solve for our x's now. You put both of them equal to 0. Add 2 on both sides, subtract 3 on both sides. Now x is equal to negative 3 and x is equal to 2. But wait, we have something called an extraneous or an exclusion. And how you find that is you set all your denominators equal to 0. And so we're not going to put the 1 equal to 0 since I put that me personally. We're just going to put the x plus 2 equal to 0. And since they're both the same thing, we just only have to do 1. x plus 2 equals 0. Subtract 2 from both sides. That means x cannot equal negative 2. So we go back down to the bottom. Do we have an x equals negative 2? No, we don't. So it all checks out. So our answer will be x equals negative 3 and x equals 2.